Imagine working long hours on an important document, only to have one badly behaved program freeze your entire computer and wipe out all your work. In the early days of personal computing, this wasn't a nightmare scenario, it was daily reality. Early operating systems offered every running program unrestricted access to the machine's memory. Any bug, a stray pointer, an array out of bounds, could overwrite data not just belonging to itself, but to other processes, or even to the OS itself. This lack of boundaries meant blue screens, system lockups, and data loss were ordinary hazards, stifling both productivity and user trust. Into this chaos stepped the concept of memory protection, a fundamental reimagining of how computers manage running programs and their data. The idea? Every program should inhabit its own isolated slice of the computer's memory, with invisible fences erected by the operating system. These fences, enforced by a combination of hardware, memory management units, and sophisticated OS logic, ensure that each application can only touch its own space. If a program misbehaves and tries to leak into forbidden territory, the system spots the violation instantly, halting just the culprit, not everything. This revolution traced its origins back to mainframe systems of the 1960s and early 1970s, but it was the rise of multitasking graphical OSes like Unix, OS/2, and later Windows NT that brought memory protection into the mainstream. Unlike their predecessors, which ran programs side by side in one giant, unguarded memory room, these modern systems gave each process its own private apartment, complete with security locks at the door. What made this so transformative? First, it finally tamed system crashes. No longer could a single rogue application bring down the whole machine. Second, it opened the door for safe multitasking. Users could run complex spreadsheets, word processors, games, and even web browsers simultaneously, confident in stability. Developers, too, found a friend in memory protection. Debugging became easier, since violations triggered clear, actionable errors instead of mystery meltdowns. And crucially for security, it forced a foundational isolation between user programs. One application could no longer spy on or sabotage its neighbors, which became ever more important as the internet era dawned. The impact was profound. Memory protection became the bedrock for more advanced concepts: virtual memory, process isolation, sandboxes for browser tabs, secure containers, and even the robust environments we now expect from cloud computing. The dominance of protected mode in CPUs, from Intel's 80386 to ARM's architectures, became a standard that no serious operating system could ignore. Every modern OS, from desktop Windows and Linux to the firmware in your phone, inherits the hard-won lessons of memory isolation. Today, thanks to memory protection, a universe of multitasking, modular software thrives, a world where you can edit, communicate, play, and create without fear that one tiny mistake could end it all. It's a quiet hero, but one that underpins everything we do in our digital lives. The next time your machine survives a software hiccup with just a polite error box, remember, the fences are working, and the blue screens are ghost.